Assalamu alaikum. Hi everyone. I am Benazir. I am a physics teacher. This is my first video on my channel. I am going to give you the basic concept of illuminating science. This video covers the topic of electrostatic and it will help you to understand the concept and properties of electrostatics. Let me start. Have you ever rubbed a balloon on your hair and seen your hair stand up? Why does this happen? Because of electrostatics. The electrostatics is very interesting and easy to understand. Let me explain. Electrostatics is study of electric charge at rest. It means not moving. It deals with the force, fields and the effect created by static electric charge. How electric charge work? Charge has three basic properties. First one is electric charge and second one is conservation of charge and third quantization of charge. You see, electric charge, everything around us made up of atoms like the air we breathe, the water we drink and even our own bodies is made up of tiny building blocks is called atoms. Atoms are like a mini solar system with a central nucleus. The nucleus contains protons and neutrons and tiny electrons moving around it. Protons and neutrons sit together in the nucleus and give the atom most of its mass or weight. Electrons are super light and move around the nucleus in specific region. You know very well the electric charge is basic properties of tiny particles. The protons and electrons make them attract and repel each other. Protons have a positive charge and electrons have a negative charge. Neutrons have its neutral. Opposite charges pull together while like charges push away. Another basic properties of charge is conservation of charge. Benjamin Franklin recognized the principle of conservation charge in 18th century through in his kite experiment 1752 and he demonstrated that lighting in a form of electricity. He also introduced the idea of positive and negative charges and observed that charge is never created or destroyed, only transferred from one object to another object. This means the total amount of charge in a closed system always stay the same. Example, static shock. When you touch a metal door after walking on carpet, the excess electron jump to the metal. See another example. When you rub a balloon on your hair, electron move from hair to the balloon. The balloon becomes negative charge and your hair becomes positive charge. But the total charge before and after is the same. The charge just moved. This makes your head stand up because like charge repel. Another example, lightning in a thunderstorm. These examples show how electric charge is everywhere in our daily lives. And another basic property is quantization of charge. The charge Q on any object is equal to an integral multiple of this fundamental unit of charge E. This means electric charge always exists in discrete fixed amount. It is not continuous. See here the mathematical representation Q is equal to NE where Q is total charge, N is any integer, E is denoted by fundamental unit of charge. This concept was experimentally confirmed by Robert Millikan and he is through the experiment found that the value of E 1.6 into 10 power minus 19 coulomb. See, when a glass rod is rubbed with a silk cloth, a huge number of electrons are transferred. Since This number is very large. In daily life application, charge appears continuous due to the transfer of an extremely charged number of electrons. At a large scale, charge seems smooth. At a small scale, charge is made up of tiny, individual packets. This means, fundamental physics, the charge remains quantized and must be considered in discrete units. Here some examples problems on quantization of charge. Example 1. Calculate the number of electrons in 1 coulomb of negative charge. Find the number of electrons in 1 coulomb of negative charge. Here, according to quantization of charge, we know already Q is the quantization of charge, N is the elementary charge. Here, Q is equal to 1 coulomb, N is equal to Q by E equal to Q is the 1 coulomb divided by E is the value of 1.6 into 10 power minus 19 equal to, we divided the answer 6.25 into 10 power 18 electrons. So we get the answer of number of electron in 1 coulomb of charge. Second example, find the number of electrons in a given charge. A body has a charge of Q equal to 3.2 into 10 power minus 19 coulomb. How many extra electrons does it have? So we use the formula for charge quantization. Q is equal to Ne. E is equal to 1.602 into 10 power minus 19 coulomb is the elementary charge. Q is equal to 3.2 into 10 power minus 19 coulomb. Solving for N is equal to Q by E equal to 3.2 into 10 power minus 19 divided by 1.60 into 10 power minus 19. We get the answer N is equal to 2. The body has 2 extra electrons. Example 3. The total charge of a group of electrons is how much total charge is carried by 5 into 10 power 9. Use the quantization of charge formula. Q is equal to Ne equal to 5 into 10 power 9 and multiply the elementary charge value 1.60 into 10 power minus 19. Multiply, we get the value of 8.01 into 10 power minus 10 coulomb. The total charge is 8.01 into 10 power minus 10 coulomb. I hope you all understanding well, and subscribe to my channel. Don't forget it.